2.3 yesterday was slope. Just don't forget you still have a homework. Okay, I thought it was me. We still have a homework that is due tonight if you didn't do it yet on quizzes on slope. All right, we are moving into section 2.2. Section 2.2 is all about graphing linear equations. Remember I told you I like to do slope first before we graph. The problem is, before we're going to graph a linear equation, you have to learn what it is, what it looks like, what forms it comes in, what are some important points on the graph of a line, and then we actually graph. So we're not going to be graphing yet. So today is just a lot of I feel like a lot of easier stuff, but we're just identifying, okay? So we're going to graph a linear equation. This is what a linear equation or function is defined to be. It is a function that can be written in the form, good old y equals mx plus b. I feel like that's the one mathematical formula that you guys always remember. You're going to be 80 years old and still remember good old y equals mx plus b. So that's a linear equation. They may give it to you as a linear function, which looks like f of x equals mx plus b. But guys, if you are one of those people who just absolutely hates function notation, then you're always allowed to cross f of x out and put a y in its place, and then you just turn it back into an equation. So don't let f of x, trip you up. All right? So that's what it means to be a linear function. If you are a linear function, then you can be either you will be written in this form or you can be put into this form. Technically, all of the equations that we have worked with this far in chapter 1, guys, they've all been linear equations. But they have been linear equations in one variable. Now we're going to start working with linear equations in two variables. Chapter 1, it was all about x. Chapter 2, now there's going to be an x and a y in the equation, all right? Another way to think of a linear equation, it's a degree 1 equation or function. What does it mean to be degree 1? It means the highest exponent on a variable is 1. So that's great, guys. That means they're basic. They're simple. Linear equations are as easy as they are ever going to get. All right, if you have an x squared or an x to the third, that's not linear because now the highest exponent isn't 1. All right? Also, the graph of a linear equation or function, guys, it's always going to be a straight line. That's why they are called linear equations, because their graph makes a line. All right, so if that's what it means to be a linear equation, it's kind of like, all right, well then what's not a linear equation? So these are all the things that you will not find in a linear equation. There will be no multiplication between variables. So guys, if you're looking at the equation and they're multiplying x and y together, that's not linear. That's not basic. All right? If you see negative 3x times z, if you see two variables being multiplied together, that's not a linear equation. Now, I know some people are like, well, I don't know, it's m times x. Remember, m is going to be replaced with a number, so it won't be a variable times a variable. All right? What if it says it's got no variables in the denominator? You are not allowed to divide by a variable in a linear equation. So if you have 3 divided by x, that ain't linear. That gets complicated, and that's not simple. All right, there are no variables under a radical. So if you have the square root of 2 times x, you can't have a variable under that square root. That's not linear. That gets complicated. That's not going to keep this simple. So these are all the things that you will not find in a linear equation. So what we're going to do first is we're just going to look at a bunch of equations and functions and say which ones are linear and which ones are not linear. Again, I'm sorry about my blue squigglies. The Word document is just mad at all of my spaces. Oh, I am going to go down on this cord. It is, and I'm not going to put it on camera. So that's going away. Okay. Done it all day. All right, so guys, look at this one. Identify the following equations as linear or nonlinear. I'm going to put yes for all the linears, and I'm going to put no for the nonlinears. So guys, if they gave you the function f of x equals 3x plus 5, and again, if you don't like f of x, put y. If you're looking at y equals 3x plus 5, to be linear, you either have to be in mx plus b form, or I should be able to put it in mx plus b form. It should be degree 1. The highest power of a variable is 1. Do you guys agree that's linear? That is already in y equals mx plus b form? This would be yes. Totally got a linear function going on. We would graph the crap out of that line right now. All right? Look at this one. P of x equals x to the third plus 2. If you don't like P of x, put a y. Guys, is this a linear equation or function when we have an x to the third going on? Absolutely not, right? The highest exponent should be 1. This is definitely not linear. That's not simple with that x to the third going on. All right, what about y equals -4 plus 7x? Is that something that is or could be written in mx plus b form? Definitely. Put the 7x minus 4 and you're there, right? This is definitely a linear equation. What about h of x, which again, if you don't like it, put y. What about y equals 1/2 x minus 3? I'm not dividing by x, I'm dividing by 2, so it's okay. Guys, does this look like something that's written in y equals mx plus b form? Yeah, we could totally graph that. This is yes. That is linear. Everybody at home, are we all right? Everybody's good? Okay. All right, what about this one? Y equals x squared minus 4. Is that linear? No, look at that x squared. We should not have anything higher than a power of 1 on any variable. So the x squared is killing us. We don't actually graph these types of equations until after Christmas. This is coming, but we're not there yet. This is not linear. All right, what about this one? Oh, fancy. Look at this one, guys. This is a function where it has 2 inputs. You plug a number in for x, and you plug a number in for y. Look what you're going to do with them. You're going to multiply x and y together. Is that linear? No, this is way too complicated. This ain't simple. This ain't basic. This is not linear. All right, f of x. Again, if you don't like them, put y. Y equals 3 divided by x plus 2. Are you allowed to divide by a variable in a linear equation? Absolutely not. Not linear. All right, what about y equals 4x? Now remember, I could always stick a plus 0 on the end if I wanted to. Is that in y equals mx plus b form? Totally. This is linear. We could definitely graph that. All right, and then the last one. 6x plus 3y equals -15. I think we can all agree it's not in y equals mx plus b form, but it is degree 1. The highest power on any variable is 1. Could I solve this for y and put it in y equals mx plus b form? Definitely. So that is still a linear equation or function. It meets all of the requirements. Okay, so guys, when we start working with linear equations and functions, they normally come in 2 different forms. They either come in y equals mx plus b, like this one, or this one. They already come in that y equals mx plus b form. Or they'll come like this, where they're not in y equals mx plus b form, but I can get it in y equals mx plus b form. All right, so now I want to be able to go over the 2 forms that the lines come in. So I'm going to skip the word problem because it's not on your homework, so I'd rather go on to the other problems on the back that are on your homework. So let me just skip this one for now. Okay, so like I said, the linear equations, guys, they're going to come in 2 forms. They're either going to come in everybody's favorite, good old slope-intercept form, or they're going to come in standard form. So slope-intercept form, that's the one we all love. That's just y equals mx plus b. So they may already have it in that great form. So guys, for example, like the first example, y equals 3x plus 5. That was already in good old mx plus b form. The reason it's called slope-intercept form is because the slope and an intercept are hidden right inside of its equation. Does anybody know what m represents? It represents the what of that line? Slope. And then the b represents the y-intercept, exactly. And the way we teach you guys to graph a line is all about using the y-intercept and the slope. So when you're in this form, it's the best because you take the 2 most important pieces of information right out of its equation and you go right to the graph. If it's not going to be given to you in slope-intercept form, then it's going to be given to you in standard form. And standard form looks like this. ax plus by equals c. So that last example on your notes, I think it was 6x plus 3y equals -15. That was in standard form, where x and y are on the same side of the equal sign, and they equal a number. So x and y are on one side, and they equal a number. The problem with standard form, though, guys, is a, b, and c are not the slope, and they're not the y-intercept. They don't have any special meaning about that line. So a, b, and C, they're kind of just random numbers to us at this point. They don't mean anything meaningful. They are not the slope or y-intercept. So that's kind of like, he's the bad guy. He's the form you don't want your line to be in because you don't know any of the important information just by looking at his equation, all right? But I can solve this for y and turn it into y equals mx plus b. All right, another thing, by definition, a, b, and c, they actually have to be whole numbers. You will never see standard form where a, b, and c are fractions. They don't allow that. To be in true standard form, a, b, and c have to be whole numbers. Okay? So again, it's kind of like this is the form you don't want it in, and this is the form you do want it in. All right, let's just identify. So I've given you a bunch of equations. Let's just identify whether they're in slope-intercept or whether they're in standard form. So guys, look at this one. 3x plus 2y equals 12. Is that a linear equation in slope-intercept or standard? This is definitely, you can say it, please. Standard, right? The dead giveaway for slope-intercept is that it would be solved for y. This is not solved for y. This is definitely standard form of a straight line. All right, what about this one? Y equals negative 5x plus 1. That's definitely slope-intercept, right? I got a slope of negative 5 and a y-intercept at 1. All right, what about this one? X minus 3y equals negative 9. That is going to be standard or slope? Standard form, right? I don't have it solved for y, so it couldn't possibly be slope-intercept. All right, what about y equals negative x minus 6? Standard form or slope-intercept? Slope-intercept, right? I got a slope of negative 1. I got a y-intercept at negative 6. All right, he's the good kind. F of x, and again, if you don't like f of x, just put a y. Y equals negative 3x. I couldn't even imagine a plus 0 on the end. Is that standard or slope? Slope-intercept. He's a good guy. All right, and then last, 4x plus y equals 0. What form is that in? Standard. All right, perfect. All right, the only other thing I want to go over with you guys is two really important points on a graph. And this is a lot of your homework is on this part, so I want to make sure we got to it. Okay. So right now in your math careers, you've basically been asked to graph straight lines. I think basically as most of the graphs that you've seen so far. So with the graph of a straight line, we're always all about that y-intercept, right? The b value. When you get to the second half of Algebra 2 and any math class after Algebra 2, like pre-calculus or calculus, it actually switches and then it becomes all about the x-intercept. So these are just really important points that you guys should definitely know what they are. All right, so the x-intercept. So guys, if you're an x-intercept, picture a coordinate plane. Let's say we had this line right there. This point right there would be his x-intercept. It's the point where a graph intercepts or intersects with an axis. So if it's the x-intercept, it's the point where the graph crosses over the x-axis. So right now, when we're dealing with lines, he's not nearly as important as that y-intercept, that b value, but he's going to become more and more important as you move up in math. All right, so guys, the great thing about intercepts is that they're not entirely unknown points. If I'm looking at an x-intercept, he's definitely somewhere on the x-axis. Maybe he's here, maybe he's there, maybe he's all the way out here. But he's definitely on the x-axis, so he definitely has some x-coordinate. But guys, what do we automatically know his y-coordinate has to be to put him directly on the x-axis? A 0. So it's not an entirely unknown point. If you are an x-intercept, then you have to have a y-coordinate of 0. So the y-coordinate is always going to equal 0 on an x-intercept. So guys, if you're looking at a bunch of ordered pairs, you should be able to pick out the x-intercepts right away because they're the ones that have a y-coordinate of 0. So for example, the ordered pair 4, 0, that's an x-intercept. It has a y-coordinate of 0. You could be the point -9, 0. That's an x-intercept. It has a y-coordinate of 0. You could be the point 57, 0. That's an x-intercept. It has a y-coordinate of 0. So they're not entirely unknown points. You will always know the y-coordinate of an x-intercept. It's 0. All right, if you're the y-intercept, the one that we're kind of used to seeing all the time, if this is the line, then that point right there is his that point right there is his y-intercept because that's where his graph crosses over or intersects with the y-axis. The chat, okay? Yep. Okay. So again, if you're a y-intercept and you're directly on the y-axis, then your ordered pair isn't entirely unknown either. You're somewhere on the y-axis, so you're going to have a y-coordinate, but what does your x-coordinate have to be to put you on the y-axis? It's got to be 0. All right, so if you are a y-intercept, then your x-coordinate is always 0. So again, if you're looking at ordered pairs, if you see the ordered pair 0, 6, that's a y-intercept. It's got an x-coordinate of 0. If you see the ordered pair 0, -11, that's a y-intercept. He's got an x-coordinate of 0. All right, same thing. You could be 0, 100. That's a y-intercept. He's got an x-coordinate of 0. All right. So now we want to be able to mathematically solve for them. It's easy when you're looking at a graph and you see, oh, look, it crosses at 5. The x-intercept is 5. Or, hey, it crosses when y is -3. The y-intercept is -3. It's easy when you're looking at a graph. But can you look at an equation without a graph and find his x and y-intercept? That's what you're going to have to be able to do. So, guys, to find the x and y-intercepts from an equation, I use what I call a cover and solve method. All right? So let's find them. So guys, this is what I do. I just get myself organized. I'm going to take this equation. Without looking at its graph, I'm going to find its x and y-intercept. So I do this. I give myself like a little T-chart just to organize my information. You obviously don't have to do this. I just do it for organizing purposes. Okay? Let's do the x-intercept first. If we're going to find the point where this graph that we haven't even seen yet crosses over the x-axis, do you guys agree that an x-intercept is going to have an x-coordinate, but what does his y-coordinate have to be? Every x-intercept has a y-coordinate of?
0.
0. Okay. So do yourself a favor. Go to this equation and let that coordinate, let that y value be 0. So guys, if I let y be 0, what's -4 times 0?
0.
It's 0. It's gone. So cover that part of the problem up. What's left? 2x equals 12. It's the cover and solve. So 2x equals 12 is left because y had to be 0. So let that part of the equation be 0 and it disappears. All right, so now you just got to solve this for x, divide by 2, and x equals 6. So this graph will cross over the x-axis when x is 6. So sometimes they have you write it as 6 and sometimes they have you write it as an ordered pair. As an ordered pair, we know x is 6 and y had to be 0. Okay? All right, let's do the y-intercept. Guys, if we're going to find a y-intercept, right, we're clearly looking for y, but who does his x-coordinate have to be? 0. So go to this equation and let the x be 0. So if I let x be 0, what's 2 times 0?
0.
It's gone. Cover that part of the problem up. What's left? -4y equals 12. Okay? And all you got to do is solve for y. Divide by -4. And you get y equals -3. So this graph will cross the y-axis when y is -3. As an ordered pair, x was 0, y is -3. Can you see it on the camera? Yeah, okay. All right, at home, are we okay? Everybody's good? Everybody's following? All righty, here we go. Let's do it again. New equation. Let's find the x-intercept. And let's find the y-intercept. Now again, the equations can look a little bit differently. This one technically like kind of standard form. It's definitely not in slope-intercept. Some students are like, well, could I minus 6 over and get it in slope-intercept? Sure. Could I add the y over and get it in slope-intercept? Yeah. I'm just going to work with it the way it is. All right, so guys, if we want the x-intercept, we're looking for x, and y has to be who?
Oh, 0.
0. So go to this equation and let y be 0. What happens to minus 0? It's gone. So cover that part of the problem up, and what's left? 3x plus 6 equals 0. And now solve this for x. Minus 6. 3x equals negative 6. Divide by 3. And x is negative 2. So this graph will cross over the x-axis when x is negative 2. As an ordered pair, that's negative 2, 0. All right, let's do the y-intercept. The y-intercept, I'm definitely looking for y, but what does x have to be? 0. So go to this equation and let x be 0. So what's 3 times 0? 0. It's gone. Cover that part up. What's left? Negative y plus 6 equals 0. And now you could minus 6 and divide by negative 1. I'm going to get a little crazy and live on the edge. I'm going to add y to the other side. And then I find out that y is 6. And your y-intercept is 6. So 0, 6 would be the ordered pair. Everybody okay? All right, last one. Now remember, in math, you never want to do more work than you have to do. So guys, look at the last one. If we're going to look for the x-intercept and the y-intercept, what form is this equation already in?
Slope.
It's already in slope-intercept form. It's already in y equals mx plus b. Who's b when you're in this form?
Y-intercept.
The y-intercept. So who's the y-intercept?
Negative 8.
Negative 8. Right? So now that would be 0, negative 8. All right, now let's get the x-intercept. I am looking for x when y is who? 0. This is where technically, when you're in slope-intercept form, my cover and solve method kind of falls apart a little bit. If I have to let y be 0, right? I can't cover that part of the problem up. I literally just have to let y be 0. So put 0 in his place. So you're basically setting the equation equal to 0. All right. So I hope everybody is going to add 8 first. And then you get 8 equals negative 2/3 x. If I'm you guys, I hope at this point you guys can divide everything by negative 2/3. So divide by negative 2/3 like you normally would to get x alone. So it would just be 8 divided by negative 2/3. Type it into your calculator like that, it does the entire thing for you. Otherwise, I'm just going to times both sides by the reciprocal of negative 2/3. They cancel. X equals. Right, I'm going to get 3 times 8 is 24. Over negative 2 times 1 is negative 2. 24 divided by negative 2 is negative 12. Okay, so at the end of the day, your x-intercept is negative 12, which would be negative 12, 0. All right, guys, here, how do you feel about that so far? Everything's okay? Everything's fine? All right. Again, these are extremely important points that in every math class you ever take, they are always talked about. All right? Everybody at home, how are we? All right? Okay? All right, so guys, you have the homework from yesterday, and then we have, I did make another quizzes. It's 10 questions. It's pretty quick again. It's pretty fast homework. It's not due until tomorrow night. So you have homework due tonight, and you have a new homework due tomorrow. If you have no questions, guys, you are good to go. You take attendance, Ms. Greener. You are good to go. Otherwise, if you have questions, hang on to me, and we'll see you guys later.
Sorry.
Yeah.
Have a good day.
You too. What's up?
So on the last one, would you be able to add 2/3 to the other
Yeah.
side?
Yeah, you could add that, and then.
And then it would be like standard form?
It wouldn't be standard form, no.
Like in the original problem, like before you split it up.
Here?
Yeah.
Oh, so if you added it over, it'd be standard form.
Okay.
Yeah.
And then on B, I subtracted 6 like before I did it.
A lot of kids do. So yeah, if you want to start moving stuff around before, then your cover and solve will definitely work.
Okay.
Yeah. If you want to get it in standard form by minusing 6, great. And if you add him over, then you have it equal to -8 and you'd be in standard form. Yep. Some students do that. That's perfectly fine. All right, let me stop this recording.